The induction motor is the most rugged and widely used machine in industry. Both stator winding and rotor winding carry alternating current. The alternating current is supplied to the stator winding directly and the rotor winding by induction, hence the name induction machine. The induction machine can operate both as a motor and as a generator. However, it is seldom used as a generator. The performance characteristics as a generator are not satisfactory for most applications. The three-phase induction motor is used in various sizes. Large motors are used in pumps, fans, compressors, and paper mills. A three-phase 15 horsepower 460 volt 4-pole 60 hertz 1710 revolutions per minute induction motor delivers full output power to the load connected to its staff. The frictional and winding loss of this motor is 820 watts. Our problem in this case is to determine the mechanical power developed and the rotor copper losses. Converting the mechanical rating of full load power to full load shaft power, we get 15 horsepower times 746, and that equates to 11,190 watts. And the frictional and windage loss we have been given as 820 watts. The mechanical power developed then is P subscript M, which is equal to shaft power plus the friction and windage loss, which gives us 11,190 plus 820 for a total of 12,010 watts. Synchronous speed, Ns, is given by dividing the frequency by the number of poles. Substituting our known terms, 60 hertz divided by 2 poles equals 30, then multiplying by 60 to give us revs in minutes equals 1800 revolutions per minute. Slip is calculated by the synchronous speed, Ns, minus the actual full load speed, N, divided by the synchronous speed, Ns. Plugging in our actual quantities, we get 1800, subtract 1710, divided by 1800 equals 0.05. Air gap power, PAG, is defined by the mechanical power at full load, PM, divided by the quantity 1 minus the slip at that power. Again, plugging in our actual quantities, we get 12,010 divided by the quantity 1 minus 0.05, and that equals 12,642. Rotor copper losses, PCU, may be calculated by multiplying the slip by the PAG, or 0.05 times 12,642, and that gives us 632 watts. And we are done. Ready to go beyond just solving problems? If you've been following my daily post and enjoying the sample problems, you're going to love this. All of these problem sets and more are now available, or soon will be, on my official course site, my stand store for electrical training. Just go to the web address that you see at the bottom of this slide, https://stand.store/GVB. In recent years, the reality of climate change has become impossible to ignore. Severe weather events are growing more frequent and more intense. For homeowners, this means that utility power outages are no longer inconveniences. They can last for hours, days, or in extreme cases, even longer. The question is no longer if, but when. You'll need a solution to keep your homes powered and your family safe. Now is the time to prepare and ensure that you're not left in the dark when the next storm hits. Here are some trusted resources to help you prevent power outages at home. 𝐃𝐈𝐒𝐂𝐋𝐀 Canada at this web address, 𝐃𝐈𝐒𝐂𝐋𝐀 USA at this web address, Bluetti Canada at this web address, Bluetti USA at this web address, and Bluetti Australia at this web address. And finally, you can get EcoFlow at this web address.